Hi, you're right. This video is mainly about modifying one variable of your car. There's a few more things I want to talk about. This is that modified car C we looked at in the last video. I also want to take you back to this sketch here. So let's just modify that sketch of the rear wing. I might just try and drag that car across. That's not what I want to do. Let's escape. Let's finish that sketch. What we're doing is sketch 7, extrusion 7. Let's modify that sketch. That's what we're trying to modify. So last time we looked at some strange variations, and one of those variations was changing that dimension to 50, and that made that back wing quite large. And you might find in the flow diagram that is the absolute best possible arrangement of the back wing to make it aerodynamic. One thing you've got to be careful of though, look from the side, you've got to make sure this actually fits in the billet. So the person in charge of inventor and in charge of actually making your car compliant as well as actually fit within the rules. One thing you might need to make sure is the car doesn't actually extend longer than required, but also it can't be taller than the billet is, and in addition it can't be wider than the billet either. So you've got those billet dimensions in your booklets. You just make sure when you've made your final car design it doesn't exceed the size of the billet. So I might just undo that change we just did. Oops. Let's go back there. Let's just look for the side again. Let's just undo. Back to where we were at the start of this particular video. One other thing you might want to do when you're modifying your car is add extra things that aren't already there. There's nothing stopping you adding new features to your car. You might want to find the plane. Let's just say I want to add a new wing to the middle of the car. So I might go to the XY plane and I might do a new sketch on the XY plane, and I might decide that I really need a new wing right in the middle of the car. So let's just draw a rectangle here. Okay, enter, and then let's just finish that sketch, and that should be new sketch. Where is that new sketch? I might undo that. That sketch has just disappeared. I'll start that again. XY plane, new sketch. I might want to draw a new rectangle. It's in there somewhere. I'm going to press E because I want to extrude that rectangle. I want to extrude it on both sides. I want it to be about 50 millimeters wide. 50. Let's make it a bit bigger. Let's make it 60 millimeters wide. Okay, so I've just added a new feature. So there's nothing stopping you adding new features to your model as well if you think they're going to help your car win. And you can obviously go put fillets on edit that as well later on if you wish. But that's how you can add new features to your car design. Now, as far as your science project is concerned, you've got to choose one variable of your car, and don't forget a variable is something that can change. You're going to make 5 different modifications to that variable and then test each of those modifications inside the flow diagram. So just as an example, I'm going to modify this wonderful little extra wing I've put in. You could modify the front wing, you could modify the rear wing, you could modify the size of the body or space in the wheels. There's a whole lot of things you could possibly modify in your science experiment. You just got to choose one thing for the science experiment. But there's nothing stopping you modifying more than one thing. Like if you've been assigned by your group to modify the rear wing, for your science project, you might try and see how the length or the width of that particular wing affects the flow and the drag of your particular car. But if you really want to get into this project, there's nothing stopping you doing 5 modifications of the length of the wing, 5 modifications of the width, 5 modifications of the height or the angle, all sorts of things till you find the optimum rear wing design for your car. There's nothing stopping you doing that. You can incorporate that into your science report to make your science report a bit more detailed, or you can just do it as part of your own team's work. To make your car the best car possible. So I'm going to pretend this is a feature of the car that we're going to use, and I'm going to modify this little feature here. So I'm going to save this first. I'm going to call this save as. This is Casey Science number 1, save. And of this feature, I'm going to modify, I think the height of this particular feature will be a really important aspect of the aerodynamics of the car. So I'm going to choose to modify the height of that, and my hypothesis is it could be that the taller the rectangle here, the lower the drag will be for this particular car. So what I'm going to do, this is my first modification of coordinate number 1. I'm going to make modification number 2. So I'm going to find that last extrusion, extrusion 16. I'm going to edit that sketch. Let's see, I want to project the geometry so I can actually see it. Not that I can see it right now, it's a bit weird. So I might just finish that sketch. I might go click on that. Oh, that's what the problem is. I don't want to create a new sketch. I want to edit an existing sketch. So let's undo. Alright, so I didn't want that sketch there, so let's delete that. Oh, what's going on? Oh, it's still in the sketch page. I'm sorry, finish sketch. I want to delete that sketch that's not supposed to be there. But I do want to edit this sketch, edit that extrusion. I want to project the geometry of that sketch. Oh, it's not going to be doing that. Oh, here we go, there's the sketch. So, finally got there. What I might want to do is edit the dimension. So I'm going to put that dimension there. And for my next car, I'm going to change that. I want to have a range of heights. The minimum height thing is going to be 3.5 mils, I believe, in this. You might want to check that though, so I'm going to make that 4 mils. So I'm going to do one modification where that height of that feature is 4 mils. Go finish sketch. That's my first. So I'm going to save this now as Casey size number 2. Okay. And all I'm going to do is go through that a few more times and keep editing that sketch. So once again, extrusion 16. I'm going to edit that sketch. I'm going to show that sketch. Now rather than 4, I might make that 5. Okay. Finish sketch. That's another modification. That's a little bit higher this time. So I might go save as is Casey Science number 3. Save. Okay, I'm going to edit that sketch again. So there's extrusion 16. Edit sketch. Let's see it first. Let's take that up to 6. Okay, finish sketch. And this will be file, save as Casey size number 4. Okay. And once again, let's edit that again. Right click, edit sketch. Let's see that sketch. Let's change that to 7 this time. Check. Finish sketch. Okay. Save as it's Casey size number 5. Well, there's already 5. That didn't take very long. That's 5 different modifications of that particular variable of the car. I haven't changed it very much. You might change it by 2 mils or 3 mils or 5 mils at a time just to see the difference. So let's just go a little bit further. Let's say I want to just let's see, edit sketch again. This could be the 10th variation. This would be up to say 15 millimeters by this stage. Okay. So I've got a whole range of different sizes of that particular feature. The variable I'm changing is the size of that rectangular feature in the middle. That's my independent variable. I'm changing that height. In the flow diagram, I'm going to be testing how the height of that particular feature affects the aerodynamics or affects the drag. So the drag is my independent variable, and I've kept everything else about the car the same. They're all my control variables, but also in the flow diagram, I'm going to have to keep the wind speed, the number of particles, the type of analysis, the direction of the car's facing. Their variable I've got to keep the same as well to make it a fair test. So I'll save this now as the last modification. File, save as Casey size number 6. Now they're all being saved as IPT files, but for the flow software, I have to save them with a new file type. So I'm going to have to actually go now to, for each one of these actually, I have to go to this. I'm going to have to go to save as. I have to go save a copy as. And now I'm going to change this from an IPT file to an STL file. I've also got to click on options just in case, because sometimes this changes to weird dimensions. So just make sure that's actually in millimeters. Then you can go OK, because it's Casey size number 6, it's an STL file. I'm going to save that now. That'll be saved as an STL file. I can close that down now. Now I can come across to my flow diagram and I can import. And I want to import Casey size number 6 STL. Notice how the IPT files or Inventor files this funny little box, but the ones that are STL files have this F for flow, which means flow can open them. That might not come up on yours, but hopefully eventually will come up with F because it means they're a flow diagram document. And there it is. There's Casey size number 6. It's been imported into the flow program. It's on its side though, so I'm pretty sure in your instruction booklets it goes through how to change the dimensions of your car. Let's see if I can look at the side. I've got to rotate that around. Let's see, orientation. Let's see, one of these has got to be changed by 90 degrees. That looks like it. Okay. So there is our car. It's in the wind tunnel right now. And as it's going to show you in your documentation for the flow booklet, you can now then go across and change a whole lot of settings. I think we've decided we want to see the drag plot. Do we want surface pressures or something else? We actually want flow lines. You can choose tubes, you can choose smoke, you can choose particles depending on what your instructions says, and you actually develop that drag plot over time. So, but this is not supposed to be a tutorial on how to run the flow software. This is just to show you the basics. You do need to look at the booklet to determine how to use the flow software.